complete the square on the general quadratic equation. We have ax squared plus bx plus c is equal to 0. So whenever I complete the square, actually whenever I deal with any of these types of quadratic equations, I always like to not have an a as the leading or a non-1 coefficient on the x squared term. So let's make it into a 1 coefficient. And the easiest way to do that is just divide everything by a. So we divide every term on the left side by a. And of course, we have to divide the right side by a as well. And so the left side will become x squared plus b over ax plus b over ax. And then I'll write c over a over here. So we have some room to add and subtract things so we can really complete the square. So plus c over a is equal to 0 divided by a, which is just going to be equal to 0. Now, when we complete the square, we've seen this multiple times before. What we want to do is take the coefficient on the x term right here. It's b over a. Take half of it. This right here is 2 times b over 2a, right? The 2's cancel out. This is just 2 times b over 2a. So you take half of it. Half of b over a is b over 2a. You take half of it, and then you square it, and you add it right here. So plus b squared, let me write it this way, b over 2a squared. And of course, I can't just add something to one side of the equation. That would change the equation. I also either have to add it to the other side or just subtract it from the same side that I'm adding it to. So I'll also subtract the b over 2a squared, just like that. Now, the whole point of doing this is so these first 3 terms right here are a perfect square trinomial. That's what completing the square is all about. And we've seen the pattern multiple times. If I have, let's say, m plus n squared, and I'm using m and n so we don't get confused with the a's and b's and x's over here. But if I have m plus n squared, we've seen multiple times, that's going to be equal to m squared plus 2mn plus n squared. And here we have that pattern now. That's the whole point behind completing the square. That was the whole point behind taking half of b over a, that's b over 2a, and then squaring it and adding it right here. We now fit that pattern. M is x, n is b over 2a, and 2mn, if I take an x times a b over 2a and multiply that by 2, I get b over ax. So this expression right here, this trinomial, the first 3 terms, it is a perfect square trinomial. And we can write it as x plus b over 2a squared. And then, of course, we have all this other business right here. And then, of course, we have all of this other stuff right here, which is negative b over, and let me just actually square it for you. So this is, so b over 2a squared is negative b squared over 4a squared. And then I have this plus c over a. But let's write it with the same denominator here. So plus, so I could have c over a, or I could multiply the numerator and the denominator by 4a. So if I multiply the numerator by 4a, I get 4ac. If I multiply the denominator by 4a, I get 4a squared. And the whole reason why I multiplied the numerator and denominator by 4a was so that we have the same denominator right here. And of course, that is going to be equal to 0. And we could simplify it a little bit more. Or actually, well, yeah, let's just simplify it next in the next step. Don't want to skip too many steps here. So you have x plus b over 2a squared. And then we could say plus, we could put the 4ac first. So we could say, well, actually, let's just say plus negative b squared plus 4ac. All of that over 4a squared is equal to 0. I didn't put the 4ac first. I just put the negative b squared there. Now, let's isolate this squared binomial on the left-hand side. And the easiest way we can do that is to subtract this thing from both sides of the equation. So let's do that. So you can imagine, we could add, if we add b, let me do this in a different color. If we were to add positive b squared minus 4ac over 4a squared on the left-hand side, those will cancel out. And we're also going to add it on the right-hand side. Positive b squared minus 4ac over 4a squared. Anything I do to the left, I have to do to the right. What do we end up with? What do we end up with? We end up with, on the left-hand side, these two guys cancel out. We have the same denominator. When you add the numerators, that cancels with that. The 4ac cancels with the negative 4ac. These just completely cancel out. And on the left-hand side, you just have x plus b over 2a squared. And on the right-hand side, you have that being equal to b squared minus, let me do that in that blue color, b squared minus 4ac, all of that over 4a squared. Now, the next thing we probably want to do, if we want to really solve for x, is to take the square root of both sides of this equation. So let's do that. Let's take the square root of both sides of this equation. And when we do that, we don't want to only take the positive square root, because x plus b over 2a, it could be a negative number, it could be a positive number. So we want to take the positive and negative square root. So we could say that the square root of, we could put the positive or negative here, or since we're taking the square root of both sides, we could put the positive or negative there. If you put the positive or negative on both sides, it's really just telling you the same thing. It really is all of the different combinations. The negative square root, if the negative square root over here equals the negative square root over here, then it's just another combination of the different positives and negatives. So you could just write it as this square root is equal to the plus or minus square root of b squared minus 4ac over 4a squared. Now, what does this simplify to? Well, the left-hand side just becomes x plus b over 2a. X plus b over 2a is equal to, and now it gets interesting. And you might even start recognizing parts of it. So let's take the plus or minus square root of the top. What is that going to be? That's going to be, and you could just take the plus or minus only of the top, because once again, the same principles apply. There's no reason why you have to do a plus or minus over a plus or minus and a plus or minus on the left-hand side. All of the plus and minuses, there's only one combination here where there's only one plus or minus on the numerator. I apologize if that confuses you. So let's write this as the plus or minus square root of b squared minus 4ac over, what's the square root of 4a squared? Well, it's just going to be 2a. It's just going to be 2a, right? Square root of 4 is 2. Square root of a squared is a. And we're almost there. To solve for x, we just have to subtract b over 2a from both sides. We just have to subtract b over 2a from both sides of this equation. The left-hand side, we just end up with our x. And then the right-hand side, we have a negative b over 2a plus or minus the square root of b squared minus 4ac, all of that over 2a. Or since we have the same denominator, we can write this as negative b plus or minus the square root of b squared minus 4ac, all of that over 2a. And we're done. We've solved for the x's. And as you see, there's actually two solutions here. There's one where you take the positive square root, and there's another solution where you take the negative square root, if this square root exists, and if the positive and negative, and if it's not 0, you're going to have two solutions. And this right here, this result we have is, look, you give me any quadratic equation. Any quadratic equation. You give me the a, the b, and the c. We could now substitute it into this formula, essentially, that we just derived right here. And I'll give you the roots. I'll give you the x's for that quadratic equation, the x's that satisfy that quadratic equation. And this formula right here for solving any quadratic equation is called the quadratic formula. Quadratic formula. And you can see it just comes straight out of completing the square. There's no mystery magic here. But it's easily one of the most useful formulas in mathematics. And I'm usually not a huge proponent of memorizing things, but it probably will benefit you in life if you did. Hope you enjoyed that.